This conference will now be recorded. This conference will now be recorded.
Very good.
This conference will now be recorded.
Very good morning, students. Welcome to this PYQ discussion sessions. So we have been discussing previous year's questions of the JEE Mains papers. So today we have got few questions from JEE Main 2021 shift 1 20th July session. Okay, we had already solved few questions. Today we'll further solve few more questions. Okay, so let us start with this problem. This problem says a radioactive material decays by simultaneous emission of two particles of half-lives 1400 years and 700 years respectively. So these are actually half-lives. Okay, T half 1400 and another one has T half. Suppose this is T half 1, this is T half 2, or let us say AB 700 years. These are years. What will be the time after which the 1/3 of the material remains? So you have to find out the time after which 1/3 of the material remains. Okay, that means if initially the number of nuclei is n0, then after which time this n of t will be n0 by 3. Okay, so this is what is being asked. Okay, this is what is being asked. We have to now solve this question, right? So see, there are two simultaneous decay for this material, radioactive material. So in such cases we have to actually find out equivalent or the net disintegration constant of the material. Okay, so suppose this material material is decaying through a particle A and particle B. Let me find out what is the disintegration constant for the one substance. So like this is the substance, it is actually decaying through B and A. Like this, if I say the lambda A, that is the disintegration constant of this is ln2 by half-life T half of this. That means ln2 divided by 1400, and this will be per year. Okay, similarly for the other particle it will be ln2 divided by T half for B. Okay, so ln2 divided by 700, and this will be per year, right? Now if I get the total or net disintegration constant, lambda net, is equal to lambda a plus lambda b. Okay, so lambda a is ln2 by 1400 plus ln2 by 700. Let me take this ln2 divided by 700 common. So I'll get here half plus 1. Okay, so that means, this is 3 by 2 into ln2 by 700. So this is what I get, the net disintegration constant. This can be further written, this will be per year in unit. 3 ln2 divided by 1400. This is the net disintegration constant. Now with this disintegration constant, if the material is getting decayed, then n will be n0 by 3 at lambda net into t. So from here I can find out the time. So this n0 I can strike them out, and this is ln3 minus lambda net into t. So we have here ln 1/3 is equal to lambda net into t. So what will be t? T will be ln 1/3 by lambda net. Okay, so I have to write it here somewhere. Let me just get some space. I have got the expression for the t. Okay, the time required expression is the time, that is ln 1/3 divided by lambda net. See, if we put this values, one more information is given as that ln3 can be taken as 1.1. So that information we will be able to use it here. Okay, so we have to find out the time t. So that is t is equal to ln 1/3 divided by net, lambda net. Okay, this is the expression. I'll just erase rest of the thing. So we have got the expression for the time. So if we find out, this will be 3 ln 2. The net value we had got 3 ln 2 divided by 14, right, of lambda. So this is ln 1/3 divided by net 1 is 3 ln 2 by 1400. This will be in years. Okay, this will be in years, and it will be found out this to be 740 years. Okay, if you do the calculation part using the value of ln 3, I think it is ln 1/3 is given as 1.1, that you can check and then go for the calculation. So this will give you the answer 740 years. Okay, now let us go to the next problem. This problem says the region 1 and region 2, the region 1 and region 2 are separated by a spherical surface of of radius of curvature 25 centimeter. As you see here, an object is kept in region 1 at a distance 40 centimeter from the surface. That means u is given 40 centimeter from the surface. The distance of the image from the surface is, so you have to find out the image distance here. See, this is actually refraction by spherical surface. If you remember the formula what we have learned, we can directly apply there and get the answer for this. Okay, so what is the formula we know for this? We know the formula is mu2 by v minus mu1 by u, then it is mu2 minus mu1 by r. This is the formula. Now look here, u is actually minus 40, right? And radius of curvature is given as minus 25 centimeters. Okay, if we put these values, and mu1, as you know, mu1 is 1.25 and mu2 is this 1.4. So if we put these values, look, I'll write the expression, last expression. I get mu2 by v, so that is 1.4 by v minus 1.25 divided by, this is mu1, okay, 1.25, that's why I'm writing here, please don't get confused. And this is this one, and now mu2 minus mu1, here it is minus 25. So I have to solve for this v. This is very simple problem. If you have to solve this problem, you have to first do this calculation, okay, then solve it. If you solve for v, solving for v will get v is equal to 37.58 centimeter. So if we solve this equation, we should be able to get, with the minus sign obviously here, minus 37.58 centimeter. Okay. Now we'll go to the next problem. This problem says the normal reaction in for a vehicle of 800 kg mass negotiating a turn on a 30-degree banked road at maximum possible speed without skidding is. So you have to find out the normal reaction. Okay, the value of the normal reaction. So here this problem is actually from the banked road. Okay, banked road means the road will be actually inclined to the horizontal surface. Okay, this will be some height. Okay, the outer edge of the road will be actually banked means it will be raised. Okay, this is actually banked road. Okay, if the outer edge of the road is raised compared to the inner edge, then this is called banked road. Here there are few things which we need to know. Are, see, this is the object. Suppose this is the car having mass m, small m. Then in the banked road, see, the normal reaction is going in this direction on the object or the car. Therefore, this normal reaction also will have two components, one along this direction, n cos theta in the upward direction, and then n sine theta in the horizontal direction towards the center. Okay, center of the car path. So these are few things. And look, the frictional force is also making an angle with this mass, sorry, with the weight, this one. Then I will have another component, the component for this f. So this, if this is theta, this will be 90 minus theta. So this is actually f sine theta, or I can say this f cos of theta. Okay, f cos of theta. Sorry, cos of 90 minus theta, that means f sine theta actually. Okay, so look, I have got normal reaction here on the upward direction and weight in the vertically downward direction and a component of frictional force in the downward direction. If we actually see the balance of the forces in the vertical direction itself, then we'll get the normal reaction. See how we can get? We'll get n cos theta minus mg minus f cos theta. Then the theta will be this angle. That means if this you take, this is actually theta. this is 90 minus theta, that is what I know. So if this actually here this angle of banking is given as 30, so this will be 60. So this, if I just take this angle 60, then I have to write f cos theta. Okay, f cos of 60. Okay, and this will actually balance each other, right? So that there will be no vertical motion. Now for the timing, we'll just not consider the other forces like other direction, horizontal direction. Here one more point is important. See here, the skidding is not happening. For that, you know, the frictional force F is equal to mu n. That means the friction will be actually limiting friction. However, here I have to find out only this normal reaction or normal reaction n. So we can actually, so cos theta is actually cos of 30 degree minus mg if I have to write mu into n cos of 60 degree is equal to 0, right? So this cos 30 is actually root 3 by 2n mg, and this is cos 60 degree means half minus mu into n by 2, this is equal to 0. Now we have to solve for n. Okay, so we have to solve for n. Let us do very simple calculation here. So n is equal to root over 3 by 2 minus mu by 2. Okay, and this is becoming equal to mg. Okay, now if we solve for n, see mg by, okay, let us see this calculation in the next page. So I have got n cos of 30 degree, which I had written already the value, this is equal to mg. So n is equal to mg. M is, so this I have to write for n. This is cos 30 is root 3 by 2, and mu n cos theta, mu has got certain value, that is 0.2, and cos 30 degree also is given some value. I would have written that value itself, that is 0.87, and mu s is equal to 0.2. So if you do this calculation, you'll be able to find out 10.2. So this is Newton. That means kg meter per second square. Okay, so this will be the answer for this question. Okay, so this was from Bank Road. Now let us go to the next problem. This problem says AC voltage 20 sine omega t and it has got a frequency 50 hertz. The AC supply has frequency 50 hertz. Is applied to a plate. Parallel plate. That means a capacitor. The separation between the plate is given. Area is given. The amplitude of the oscillating displacement current for the AC voltage is. So we know capacitance is epsilon 0 A by T. So this is for air capacitors. C is equal to epsilon 0 A by D. So epsilon 0, value of epsilon 0 can be obtained from the question itself. Now this A is 1 meter square, D is 2 millimeter. Let us find out this. See, I can make 4 pi epsilon naught divided by 4 pi. So 4 pi epsilon naught will give you 1 over 9 into 10 to the power 9. Into 9 also will be there. This will be 1 meter square. And this D is given as 2 millimeter, 2 into 10 to the power minus 3. So from here, if I do the calculation, I will get the C. So what is the value of C? Actually, it will come little bigger in this one with 10 to the power 3. Okay, so epsilon 0 A by D, these are all fine. So I should have got, okay, D is here, fine. Okay, so then once you get this C, you have to find out what is XC. Actually, what we need to find out, we need to find out the displacement current through the the space between the plates. So that is same as the external current, that is the circuit current or conduction current. So that I have to find out here. So conduction current maximum, right? So maximum is amplitude of the conduction current. So that will be V0 by XC. Okay, V0 is given here 20, right? Then you have to find out XC. Once you get C, we can find out easily the XC. Okay, and if we put this, see XC will be, if you do this calculation, 1 over omega C. If you do this calculation, XC is equal to actually 18 by 25 into 10 to the power 6. So if I put this XC here, let us do that. Yes. So this is actually 20 into 10 to the power, sorry, 20 into 5 divided by 18. So this is 10 to the power minus 6. This will give you the ampere, okay? And if you do this simplification, what you might get, you will get 27.74. Okay, so this will be in microampere. All right, so this is actually the answer for this question. Let us go to the next problem. This problem is very, very interesting. This problem is actually from photoelectric effect combined with hydrogen atom or atomic nuclei. So the question says the radiation corresponding to 2 to 3 transition of hydrogen atom. So if I have levels like this, at least I have 1, 2, 2 and 3. So these are the energy levels, and each of them have different value of energy, right? So the electron passes through magnetic field is this. Assume the radius of the largest circular path followed by the electrons is 7 millimeter. So the question is here, what is the work function of the material? See, work function can be found out by two ways. At least one I can write. This is the energy of the incident photon minus the kinetic energy of the electron. Okay, so here if I have a transition n is equal to 3 to n is equal to 2, this is n is equal to 3, say, sorry, n is equal to 1, this is ground state, this is first excited state, this is second excited state. Each of them have actually individual energy levels, right? These are, so this guy will have energy this much, this will have 3.4. Okay, I'm sorry, this level will have energy 3.4 ev, and this, the energy gap with this to this will be 13 centimeter, sorry, 13.6 centimeter. 13.6, I'm sorry, this is actually in the unit of ev, not centimeter. Yeah, so this is the one. So these are actually the energy differences written 1 to, this is actually from 3 to 1, so that's why the whole, see, this energy will be 13.6. Okay, and this will be 3.4, and this will be 1.51 electron volt. Now I have to find out 3 to 2 transition. 3 to 2 transition will be energy will be how much? 3 to 2 transition, that means this to this. Now we have to actually find out the radii of the circular path. Okay, so once I get the energy, say 2 to 3, sorry, 3 to 2, let us say 3 to 2, the energy will be 1.89 ev. You can just cross check this. Okay, okay, so here magnetic field is given as 5 Tesla. Okay, 5 into 10 to the power minus 4 Tesla. Okay, so we need to find out work function. So before that, let us check few more things. So we know R is equal to m v by qb for circular path, for cyclotron motion. qb, q is the charge, and see E is equal to p square by 2m. Sorry, this p square by 2m is q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from here actually we would be able to find out mv, and this will be q. So from So here actually we'll get mv from here qbr. Okay, then E is equal to p square by 2m, so it will be half mv square. From here actually kinetic energy will get p square by 2m, right? P mv we have already got, so qbr. Divided by 2m. If we put all this value carefully, k e, see this qbr, this we can, so now what we'll do, we'll do the simplification, okay, for this particular energy. Okay, so q here, see this electron actually, so it will be 1.6 into 10 to the power minus 19. Okay, and then so I have calculated these things. I think better I'll write, see this q is equal to 1.6 into 10 to the minus, I'm sorry, this is actually charge of q. So charge of q, I just wanted to write, that is actually 1.6 into 10 to the power minus 19 coulomb is, so we have to actually find out the energy here. What is the energy? From this calculation we will be able to get this energy. So what will be the energy? This is the energy of the photon, emitted photon, that is actually, sorry, um, the photon with which the bombardment is required. So that will be actually, see from here itself, okay, qbr, qrb. So this is r actually. I think I had written capital R. Let me go with capital R. Okay, if we put all these values, and in the denominator there was actually 2m. Yes, it will be 2m. If we put the values, all the values, b is 5 into 10 to the power minus 4. Then this q is the charge of electron. This is b as the magnetic field given, and r is the radius given. So then we'll get this energy equal to 1.89 eV. This is actually 9. So phi will be photon minus of this will be actually K kinetic energy. Kinetic energy of the electron that we have already found out. This is Ek. Then from this formula, see this differentiation when we take. Okay, sorry. The difference when we take. Let us see this E of the incident radiation and there was kinetic energy of the electron, maximum kinetic energy of the electron. Okay, so if we put these values, I'll be able to get this as 1.077. I'm sorry, I think I have done a little mistake over here. You just look this E is equal to P square by 2m where we had written P is equal to again mv P is equal to actually QRV. This is 2m. Okay, so this E will actually come as 1.077 EP. Okay, in electron volt. Okay, then incident photon energy we have already obtained here, that is 1.89 ev. So what we had to get, we had to get work function. The e I had got like this, and this energy is actually the kinetic energy of the electron, ek. Actually this is ek. Energy of the photon we had got 1.89 ev. So work function will be not ev, this is e nu minus ek, that is 1.89 minus 1.077 electron volt. This will give you 0.813 AV. Okay. We can see the options. The first option will be actually correct for this. Okay. The first option will be the correct one here. I think I'll stop it here for today with this. In the next class, we'll take the remaining questions of this set. Thank you.